So welcome to our spring sustainability seminar series. I'm Kishore Rajagopalan, Associate Director at the Illinois Sustainable Technology Center. For those of you who are new or joining us over the web, the mission of the center is to advance sustainable practices, reduce pollution, and enhance human and environmental health. We are one of 5 surveys organized within the Prairie Research Institute. The Institute, through its objective, integrated research, seeks to ensure sustainable economic development, enduring environmental quality, and cultural resource preservation for the people, businesses, and governments of Illinois. The goal of this spring sustainability seminar series is to listen to various perspectives on sustainability-related issues in Illinois. Over the semester, we have heard from many different organizations, both private and public, from all over the state. Today, we are focusing on sustainability at home. I'm pleased to welcome today's speaker, Dr. Ben McCall, from the Institute for Sustainability, Energy and Environment at the University of Illinois, Urbana-Champaign. Professor McCall received his BS degree in chemistry from the California Institute of Technology in 1995 and a joint PhD in chemistry and astronomy and astrophysics from the University of Chicago in 2001. His research interests are in the overlapping areas of high-resolution molecular spectroscopy and interstellar chemistry. But today he's taking a break from staring into space and putting on his hat as Associate Director for Campus Sustainability. In that capacity, he will be talking about the reorganized Institute for Sustainability, Energy and Environment, and its vision and strategies for a more sustainable campus. So before we get started, a couple of housekeeping points. Restrooms are in the hallway across the reception and through the door to my right. And in case of an emergency, please stand up and follow my instructions. With that, Ben, it's all yours. Thank you.
Thanks very much. Thank you. It's a pleasure to be with you today. And so I'd like to talk about our new Institute for Sustainability, Energy, and Environment, some of the challenges that I see that we face in sustainability in general, and the approach that our campus is taking to become more sustainable, and the progress that we've made along the way. So I'll start off just by mentioning this new institute. Our mission is to conduct actionable research, to educate the next generation of leaders to address grand challenges in sustainability, energy, and environment, and to move our campus and community toward becoming a global model of sustainability. So we're basically a 3-legged stool of actionable research, education and outreach, and campus sustainability. The research side is headed up by our director, Professor Evan DeLucia from the Plant Biology Department. And we are initiating major efforts in 5 cross-disciplinary themes. The initial aim of the Institute is to provide seed funding to get groups of researchers from across campus together to tackle some of these big problems and come up with actionable solutions. In terms of education and outreach, this is being led by our Associate Director, Professor Madhu Khanna from Agricultural and Consumer Economics. She has a lot on her plate, but what she's focusing on most right now is the development of a new undergraduate minor in the area of sustainability. And what I'm going to focus most on today is campus sustainability. That's my bailiwick. So I'm kind of the lab rat of the group, and I'm the one who's kind of more in tune with infrastructure and turning knobs and bolts and wrenches and things like that. And our goals are really to drive the campus more towards sustainability. So I'm a lab rat, but I'm also an astronomer. And as an astronomer, I have a different perspective on our planet than a lot of people do. So this is Earth here, this little pale blue dot as viewed from Cassini orbiting Saturn. So we are a small planet, even though it feels very large from where we're standing. And this is another beautiful image from Apollo 8 in December 1968, an iconic image of our planet as viewed from somewhat afar. And what's most remarkable to me about this image is that this is an image of a sustainable planet. In 1968, we had 3.5 billion people on the planet, and the atmospheric CO2 concentration was 324 parts per million. Those were levels that were sustainable. But over the years, as technology has advanced and our space program has advanced, the number of people and also the CO2 concentration in the atmosphere has been rising and rising, such that today we have 7.2 billion people and almost 400 parts per million of CO2. Both of which I think are widely acknowledged to not truly be sustainable numbers. So I want to mention these CO2 measurements. The CO2 measurements in our atmosphere were pioneered actually by an alum of the University of Illinois, Charles David Keeling, a chemistry major actually, so from my department. In the late 1950s, he began very careful and systematic measurements of the atmospheric CO2 concentration on Mauna Loa in Hawaii. And that series of measurements has persisted to the present day. And what you see is this relentless rise, modulated by seasonal variations, of the CO2 concentration, such that we're now flirting with 400 parts per million of CO2. So a lot of people wonder if this is a natural variation or if this is something unusual. And that can be answered by looking back in time at ice core data. And so here's a historical perspective on this from 1700 to the present. There's been essentially an exponential rise in CO2 concentration during that time period. And if you look even further back in the ice core record, this is now almost 1 million years, you'll see that the CO2 concentration has never been anywhere close to 400 parts per million. In fact, the CO2 concentration has basically been bistable. It's either at this low level of around 200 parts per million, which constitutes an ice age, or it's at this higher level of 280 or so parts per million, which constitutes the so-called interglacial periods. And we've been sitting in an interglacial period for about 10,000 years or so. Nice, mild weather climate that has enabled us to develop things like agriculture and cities, things that we really appreciate as a modern civilization. And we are now taking the planet way out of that range into a place that the planet has not been, at least for 1 million years, and certainly a place that humans have never seen. And this is unquestionably our doing. This this rise in CO2 concentration has followed in lockstep with the emission of carbon dioxide from the combustion of fossil fuels like coal, natural gas, and petroleum. So because we found this amazing treasure trove of energy sources in the earth and started burning them as fast as we possibly could to grow our economy and provide lots of benefits to human civilization, we have essentially polluted the atmosphere by adding all of this carbon dioxide. As many of you know, this has led to an enhancement of the natural greenhouse effect on Earth, leading to a global average temperature increase. This has been really nicely illustrated by Jim Hansen from NASA Goddard, talking about this concept of climate dice. You know, every summer you get whatever weather comes. It's like a roll of the dice, but now the dice are loaded. You're almost always going to get hotter than usual summers. And there's been a very clear shift in our climate from the temperatures in the 1970s, for example, to the first decade of the 21st century. We have already changed the climate on the Earth by increasing CO2, and we continue to pump out CO2 at ever-increasing rates. Another influence of this carbon dioxide concentration has been the widespread melting of Arctic ice. So we had a record low Arctic sea ice in 2012. This is just an amazing map showing the median sea ice extent and then what we had in 2012. The loss of Arctic sea ice is making the problem worse because ice is reflective of sunlight, ocean water not so much. And so we're sucking up more of the solar radiation because we have a darker planet to present to it. Furthermore, it's impacting weather patterns, making the jet stream become more stationary, leading to longer periods of intense drought or intense precipitation. So a lot of scary things are happening to our planet. Sea level is rising, already very clearly rising. The ocean is acidifying. We're having increasing droughts, more intense hurricanes, crop losses, biodiversity loss, extinctions, and a really scary idea that we may be reaching tipping points on our planet where the CO2 concentration gets high enough, the temperature gets warm enough that we start to do things like melt permafrost and release even more CO2 and even worse methane into the atmosphere, which may push us kind of beyond a point of no return in the climate system. So this is a really scary thing, what we're doing to the planet by emitting all this carbon dioxide. But this is just one of what I see as two really major challenges facing humanity. And the other huge challenge is the depletion of natural resources that we've come to be very dependent on. And this was first elucidated by M.K. Hubbard, a petroleum geologist at Shell, in 1956, about the same time that Charles David Keeling was starting those CO2 measurements. M.K. Hubbard predicted at this time that even though the U.S. petroleum production had gone up and up and up to 1956, that it would reach a peak and ultimately turn over, because after all, there's a finite amount of oil underneath the United States. He was widely derided as kind of crazy for suggesting this, because imagine yourself sitting here in 1956 where everything had been going up and up and up, and here's this guy forecasting gloom and doom that all of a sudden we're going to start running out of oil. But then if you look at the actual data since that time, this black curve pretty well matches his prediction from 1956. Here's an updated figure that shows not just the crude oil in the lower 48 states, which is the green curve, which very clearly has been decreasing like crazy since 1970. But we've also added on some new ways of getting oil, such as Alaska, looking offshore in the Gulf of Mexico, and very recently this effect of hydraulic fracturing, or so-called tight oil. But we have been going down in our oil production in the United States. And what's true for one country must be true of the entire planet as a whole. This is a forecast from the International Energy Agency, which is a very conservative group that has tended to paint a very rosy picture of future energy supplies that have not really come to pass. But this is their recent prediction. This dark blue curve is conventional oil production from currently producing oil fields. And you see that it's kind of peaking around 2005 and then gradually declining beyond that point. IEA is very optimistic. They say that there are fields that are yet to be developed, these light blue bars that will fill in some of that, and that there are fields yet to be found which will make up even more of oil production. But that's, you know, a little bit questionable. And then also on top of this are things like natural gas liquids and light tight oil, other sources that IEA say will provide us more and more energy going into the future. But one has to keep in mind the fact that this type of energy supply is more expensive to produce and has a lower energy content and takes more energy to get out of the ground than the conventional oil that we have come to rely on. So even if the total amount of energy sources available may be steady or increasing, the availability of low-cost, high-quality energy sources is declining. And I just wanted to pull out this quote from a recent paper in the Philosophical Transactions, that a sustained decline in global conventional production appears probable before 2030, and there's significant risk of it beginning before 2020. And these authors suggest that the inclusion of tight oil from hydrofracturing appears unlikely to significantly affect the conclusion, partly because it's a relatively modest resource base. So people say, drill, baby, drill. Let's just go find more oil, but the Earth is a finite object, and there's only so much oil to be had. So I've been studying these questions over the past few years, and the conclusions that I've come to are, first of all, that we have to stop emitting carbon dioxide into the atmosphere if we want to have any hope of continuing our civilization in the manner that we've come to be accustomed to. In addition to the carbon dioxide problem, I think the era of cheap oil is over. It was over several years ago. Oil is now $100 a barrel and has been that way for a long time. Despite such high prices, production has not been increasing. So we are kind of reaching the point where we might find new ways of producing oil, but it's not going to be cheap. The era of cheap natural gas probably will be ending soon. Hydraulic fracturing has been a big boon, but it's unlikely to last for more than another decade. And a lot of people are suggesting that the era of cheap coal may also be ending before too many more decades go on, because, again, coal is a finite resource, and we're turning more and more to coal. So this is kind of an interesting challenge for us, since economic growth depends on growth in energy resources. Population growth also depends on having more energy. And even modern agriculture is very dependent on fossil fuels, both directly in terms of running tractors and transportation and things like that, but also indirectly in the production of fertilizers. So I think we have immense and profound challenges ahead of us to maintain the type of civilization that we've become accustomed to. So many people react to this news with unpleasant emotions, and I don't blame anyone for feeling that way. I kind of felt like this as I started to learn more about climate change and resource depletion. But Pat Schroeder once said that you can't wring your hands and roll up your sleeves at the same time. And my feeling is that we really need to roll up our sleeves and become more sustainable, take active steps to try to solve these problems. So Daniel Burnham, who's often called the architect of Chicago, once said, "Make no little plans. They have no magic to stir men's blood and probably will not be realized. Make big plans." So I'm happy to report that our campus has made big plans. We have a plan called the Illinois Climate Action Plan to become completely carbon neutral by the year 2050. That's a huge challenge. How are we going to go from the immense amount of carbon dioxide emissions we have right now to nothing in just about 35 years? Well, the Illinois Climate Action Plan put together this so-called wedge diagram. This gray curve shows our historical emissions up to the time of the iCAP, and this top-level curve are the anticipated emissions according to business as usual. And then these different wedges represent things like energy conservation, renewable energy, putting a limit on our space growth and so forth, different ways of reducing the CO2 emissions from what it would be in 2050 down to zero. And the great news to report is that our actual emissions are shown here by these black dots. They're considerably lower than the business as usual projection, and they're actually even lower than what iCAP had forecasted with various measures taken into place. So in the last fiscal year, we are 200,000 tons of CO2 emissions lower than business as usual, and 100,000 tons lower than the expectation from the Illinois Climate Action Plan. So that's really great news. We've made some really good progress over the past several years, but on the other hand, we're still emitting something like 500,000 tons of carbon dioxide every year into the atmosphere, and we need to drive that down to zero. So this new institute, the iSEE, has put together a new initiative called SWAT teams, Sustainability Working Advisory Teams. And the idea is to bring together experts from across campus in 6 key areas related to the iCAP: energy conservation and building standards, energy generation, purchasing and distribution, purchasing, waste and recycling, agriculture, land use, food and sequestration, transportation, and water. So we want to bring people together to study these questions, to come up with concrete, actionable solutions that our campus can undertake to improve in these various regimes. Each of these teams consists of a core group consisting of 2 faculty members, 2 students, and 2 staff members. Most of the SWAT teams have representatives from facilities and services, as well as people from across campus. Each of these SWAT teams is going to be surrounded, if you like, by a consultation group of other stakeholders and experts from across campus to provide input into the SWAT teams and also to provide feedback on what the SWAT teams come up with. And then we also envision a very healthy and robust public input process to get the broader campus community engaged as well. So I'd like to, in the remaining time, kind of go through what the iCAP targets are for each of these 6 areas and say a few words about how we're doing as judged by the preliminary assessments that these SWAT teams have put together. So in the first area of energy conservation and building standards, the iCAP demands that we reduce existing building energy consumption by 20%. This is all based on the fiscal year 2008 baseline, by fiscal year 2015, and then further conservation up to 40% by 2025. So we've actually done much better than that already. This is a graph of our energy use intensity in BTUs per square foot per year. And in fiscal year 2008, we were sitting here at 300,000 BTUs per square foot per year. In fiscal 13, we were down to 223,000. That's far below this red line, which is represents the iCAP goal. So we've already exceeded that metric. A second target was to offset the greenhouse gas emissions from the supercomputer when the next contract renewal comes up. That's in 2016, so we're still looking forward to that discussion. The third was to implement a no net increase in space policy, so as to put a lid on space growth on our campus to prevent future increases in energy demand. And then finally, that new buildings and renovations should be either net zero or net positive energy providers by 2025. In the area of energy generation, purchasing, and distribution, there were really two top-level targets. One was a goal to obtain a certain fraction of our electrical energy demand from renewable sources. That's 5% by fiscal 15, 17.5% by 2020, and 25% by fiscal 2025. The second goal was to end coal usage at Abbott by 2017. So in terms of renewable electricity, I'm pleased to report that it looks like we're going to make this 5% target by 2015 through a combination of a solar farm, which we expect to be installed in the coming fiscal year, and also through the purchase of renewable energy certificates. Getting to larger percentages, like 25%, is going to be a huge challenge, as is ending coal usage at Abbott Power Plant. And I wanted to advertise that we're going to be having an energy retreat on Thursday, May 8th. Everyone from the campus community who's interested in the energy future of our campus is welcome to join this. It's being sponsored by the SWAT team on energy generation. It's going to be held in Noise Lab, room 161. So feel free to join us or email me later if you want to get a reminder about that. In terms of purchasing, waste, and recycling, there are two targets. One is to develop a long-term zero-waste campus policy. Such a policy has now been drafted and is being refined, and we're hopeful that we can get that approved by 2015. The second target is to increase waste diversion to 75% by 2020. That's a goal that I think was ill-constructed because we're already much better than that if you count all of the waste on our campus. We're, I think, something like 80 or 90% waste production right now, waste diversion from the landfill. But that's misleading because it's almost all agricultural waste, which we do a very good job of reusing on the South Farms. So if you actually look at metrics like the number of millions of pounds we send to the landfill each year and millions of pounds we recycle each year, unfortunately the landfill has gone up and the recycling has gone down. So we clearly have some challenges ahead of us on our campus in terms of increasing ordinary or non-agricultural waste from the landfill. In terms of agriculture, land use, food, and sequestration, there are two top-level targets. One is to reduce our agricultural emissions by 50% by 2020. It turns out to be actually quite challenging to even calculate our agricultural emissions. And so the SWAT team that's tasked with this has a job ahead of it to really better quantify what those emissions are, and then to try to figure out how we can further reduce them. But the second target is more quantifiable: purchase more than 30% of our food locally by 2015. There have been great efforts made by our dining services folks on campus, and we're actually already quite close to meeting that target, and I think we will meet it by 2015. In the fifth area of transportation, the target is to reduce emissions from air travel, commuting, and fleet vehicles by 30% by 2015, and then up to 50% by 2025. Unfortunately, we've done a very bad job in this department. This is a graph of the tons of CO2 emitted from fleet vehicles, faculty and staff commuting, and directly financed air travel from 2008 to 2013. And our target is shown here in this black line. And the fleet vehicles and faculty and staff commuting have actually gone down a little bit since fiscal 2008, but directly financed air travel, as you can see, has been growing rapidly. And so that represents a real challenge. How do we develop incentives to reduce the amount of air travel that people on campus undertake when all of the professional sort of incentives are to travel more, to go to more conferences, give more invited talks, things like that. So this is going to be a big challenge for us. In the sixth area of water, the target is to reduce potable water usage by 20% by 2015, and then up to 40% by 2025. And this is a good news story. We have actually reduced our water usage on campus by more than 20% already in fiscal 2013, thanks to a lot of great efforts by facilities and services, both in terms of installing low-flow fixtures and also in working on eliminating leaks from the campus infrastructure. So that's kind of where we are in terms of these different areas of the Illinois Climate Action Plan. Just to briefly recap that, there are 8 top-level targets in the iCAP that had dates of 2015 or earlier. Those were to reduce existing building energy consumption by 20%, which we've done, to reduce the associated greenhouse gas emissions by 15%, which we've also done, to purchase 30% of our food from local sources, and we're almost there, to reduce potable water usage by 20%, and we've done that already, to implement a no net increase in space policy. That has not yet been done, but we're having great discussions with a committee that was charged by the provost with this task, and I think we're making good progress. I'm still optimistic that we'll be able to accomplish this by 2015. 6th is to develop a long-term zero waste policy. As I mentioned, that's been drafted, but not yet approved. 7th is to get 5% of electrical energy from renewables, which I think we're on track to meet. And 8th, to reduce greenhouse gas emissions for transportation by 30%, which we have not done, and it's really not clear how we might be able to achieve that. So I made this talk short so that there'd be plenty of time for questions and answers, especially since I have to leave a little bit before 1 o'clock. So I just want to summarize by saying that we have a lot of work to do. We need everybody's help from across campus. So you're very much welcome to join us pitching into this effort however you can. If you're interested in serving as part of the consultation groups for these SWAT teams or contributing in any way, please contact me. My email address is campussustainability@illinois.edu. Hopefully that's fairly easy to remember, but if you don't remember that, try to remember our URLs, sustainability.illinois.edu. And let's not keep calm and carry on. Instead, let's raise hell and change the world. So thank you very much for your attention, and I'd be very happy to try to answer any questions you might have. Yes.
I was curious if you could expand upon, this talk was about all the great things you've done, I think that's excellent, but maybe expand upon areas to work further on, or how to use the campus as a living laboratory, and maybe what those funding sources are as well.
Sure, that's a big question. So the first part of it, I think, is with these SWAT teams. So they are charged with examining these different areas and coming up with concrete ideas of how we can improve. So to take one example, just off the top of my head, energy generation. On campus, we have a coal plant, we have a lot of gas boilers and gas turbines. How are we going to reduce the emissions from that plant to 0 by 2050? We're clearly not going to do that by burning coal or burning natural gas. We're going to have a complete transformation in the way that we generate or at least purchase energy on this campus. So my hope is that these teams, will study these issues, come up with recommendations, and then the campus is developing a procedure by which these recommendations will be evaluated by different levels of administrative authorities, going all the way up to the chancellor's level, so that when we have big questions like, can we spend $100 million to replace a boiler or something, there's a very clearly defined pathway by which those sorts of recommendations would be considered and evaluated. So that's how I kind of see us moving forward procedurally. I'm not in a position to answer the question of how we're going to do all of this. I don't have all of the expertise necessary to do that, and that's the reason I wanted to get 36 people on board in these SWAT teams, plus all the consultation groups around them to tackle these issues. But I think what we're doing is setting in place a mechanism by which we can start to tackle these questions in earnest. And what I've been really happy about is the participation that we've gotten from facilities and services in this effort. They seem to be very, very open to this. They see their mission as serving the campus, and they need the campus to help them understand, what the goals are, what the needs are in terms of sustainability. I don't think I answered the whole question. There were some other parts.
I guess, funding part of it, but you mentioned also, getting approval, I think, is part of the story.
Right. So in terms of funding, we do not have a budget in iSEE for campus sustainability. Instead, the idea is that we would be, leading this campus-wide consensus for how we want to change the processes, not just at FNS, but in housing, in other auxiliary services, all across campus, and working within those existing budgetary streams to, to try to make change happen. Yes, sir.
Are the dorms a significant user of energy, and is there a breakdown of such things as the impact of individual refrigerators in individual dorm rooms and things of that nature and their impact on the overall campus usage?
Yeah, that's a great question. I don't have. Oh, I'm sorry. That's why I have to repeat the question. So this question was, is there a breakdown of the fraction of energy that is used by the dormitories, and how that's influenced by things like dorm fridges and things like that. The data, we do have data by building of how much energy is used. I don't have that on the top of my head, and it's an interesting question. I've not added up all the dorms and seen what fraction of the energy that is. We don't have data on things like individual refrigerators, and that's a problem, I think, not just in dorms, but also in offices across campus. A lot of people have individual refrigerators. A lot of people even have space heaters under their desks because the air conditioning is cranking out of control and things like that. So I think that's going to be a major target of this conservation group, is trying to better analyze what the major sinks of energy are on campus and how we can change policies to try to improve those. It's a fantastic question, though. Yes.
You mentioned campus and community early in your presentation. Can you talk about how iSEE might benefit sustainability in the community around the campus?
Sure. The question was how iSEE will interact with the community and try to improve sustainability across the Champaign-Urbana metroplex. So this is an area that is kind of an overlap between my area of campus sustainability and Madhu Khanna's area of outreach. And it's a question that we're still kind of trying to formulate within iSEE how that is best going to work. From my perspective, I see part of our role as being a model for how what is essentially a small city can become carbon neutral. And hopefully we can export at least some of the ideas from that experience, not just to our surrounding community municipalities, but also across the state. In terms of more concrete steps, I think we are very interested in partnering with the cities to examine how we can work together on various things. Transportation, for example, is one area where there's a lot of linkages between the campus and the cities and CUMTV, for example. So I think there are great opportunities for partnerships there as we move forward. Yeah?
How were those teams selected?
How were the SWAT teams selected? So this was done in a collaboration between the Institute and Facilities and Services, since we felt that most of the impact of the outcomes of these teams would at least be centered in FNS. Of course, they're not the only unit that would be impacted. But we thought that iSEE and FNS are the two largest stakeholders in this operation. So we basically sat down and identified experts from across campus. We wanted to get a breadth in discipline among the faculty. We wanted to get people both from FNS and from other units as the staff members. And then in terms of students, we worked with some of the student organizations on campus to identify representatives that kind of had the best overlap with these teams. To amplify a little bit on the process that we envisioned, we envisioned these being kind of annual terms, so that people would maybe serve more than 1 year, but ultimately people are going to either graduate or need to move on to other things in their career. So these teams are going to be permanent fixtures on our campus, but the membership will rotate over time. Yes?
What part of the waste on campus is from lab waste, the waste that is from labs, and how is it used in campus?
Okay, the question is what fraction of our campus's waste is from laboratories and what is being done to tackle that. It's troubling to admit that I think we have very little sense of where the waste on campus comes from. The only cross-campus inventorying of waste that occurs is when it leaves the campus in the form of tipping fees to a landfill or sale to recyclers and things like that. There have been small-scale studies done on individual buildings, but I don't think that a lab-intensive building has been targeted with that. Someone's telling me no.
Other than ours here.
Other than yours here? Okay, great. So I think we have a lot to learn about how the waste is being generated on our campus and what we can do to improve that. I'm familiar with an effort to try to get nitrile glove recycling across the campus. I think ISTC had a major role in getting that going. I think that's a really exciting thing. But this question is really a central question, right? In order to reduce our waste, we need to understand what it is, how it's being generated, and only then can we try to take some steps to reduce it. That's clearly something that we're going to have to do a better job as a campus on. Yes?
The focus of this is obviously the carbon and energy interface, but the words campus sustainability imply a much broader range. And is somebody watching or encouraging some of the conservation-related aspects of sustainability, such as the insects and plants, variety of tree species, etc., because some things could be implemented that take us to a monoculture or actually decrease the diversity of plant and animal life, which is already under severe strain. So what do you see iSEE doing to keep some of these other functions in focus?
Sure. I'll try to summarize the nut of the question. I talked a lot about carbon dioxide, and what about other areas of sustainability, especially biodiversity and things like native landscaping and so forth. It certainly is within our mission of campus sustainability to tackle questions like biodiversity and the way that we do landscaping on our campus. And in fact, the Illinois Climate Action Plan itself is a much broader document than just carbon dioxide, even though the very top level goal is carbon neutrality by 2050. Things like water management, stormwater, biodiversity are very important things in that plan. So in terms of these SWAT teams, for example, one of the teams is called Agriculture, Land Use, Food, and Sequestration. And I view most of these things that you mentioned in terms of biodiversity, how we choose plantings on campus, as part of the land use mission of that team. And I mean, we have had a lot of discussions already with folks on campus about ways that we can improve the sustainability of the landscaping and reducing monocultures and non-native plants. So that's certainly an area that we're very interested in, even though it's hard to put a number on that, right? The CO2 is really easy to quantify. Yes?
Have you collaborated with other universities such as Ohio State, Michigan? They seem to be way ahead of us on sustainability. You ever work with those people? Or
I am.
Reinvent the wheel?
No, that's a great question. So the question, just to repeat that, was to what extent have we been collaborating with folks at other universities who are tackling these same sorts of questions? So, we're pretty new on the job here, and we're still forming a network of people at other campuses. I've been in pretty close touch with my counterpart at University of Illinois in Chicago. We've discussed a number of issues, and I'm kind of slowly building my network of contacts with folks at Cornell, for example, is a campus that has been really aggressive in this area. And we've, even though we haven't started talking with a lot of people, we've been doing a lot of studying of what other campuses have done. So that's clearly a very important thing to do. We shouldn't reinvent the wheel, right? We should be inspired by what other people have done and try to adapt those strategies to the unique aspects of our campus. It's fair to say that there are campuses that have done a much better job than we have, but the more I've learned about what we do on this campus and what we have been doing, the more I'm convinced that we're actually not at the bottom of the pack in any sense at all. We have actually done some remarkable things. And there are some systematic things in in terms of our campus that really set us apart from others. One example is the Student Sustainability Committee on campus. Students assess fees on themselves to fund sustainability projects. That's not unique, but we have by far the largest such fund of any university in the country. So we have some really good things going for us, but we definitely need to learn from what others have done. Other questions? I can stay for a few more minutes.
You have 1 minute. So let me ask you this question. Can you expand on the actionable research part of iSEE? You said that you don't have funding, but campus sustainability does not seem to have funding. What does it say about what are the priorities of iSEE?
Well, I think what it says is, in my view, the question, sorry. The question was, just start over here. The question was, what does actionable research mean, and why does iSEE have funding targeted toward research and does not have a budget line targeted toward campus sustainability? And does that say something about the priorities of iSEE? Okay, so first on actionable research, I think the idea here is that we want to jumpstart efforts that will have transformative effects in these areas that go beyond the sort of basic research that's, so much of which happens on our campus, to things that are going to have a real tangible impact on the world in the 5 to 10 year sort of time frame. So I think that's what we mean when we say actionable research as opposed to just important research. In terms of the funding model for the Institute, my impression of that is that it's essentially impossible to bring faculty together and catalyze new collaborations and new research thrusts without providing a little bit of seed money to help that initiate. And that's the reason why funding was directly allocated to setting up these 5 research themes. I didn't talk much about this, but incidentally, the idea is that as those themes grow, those groups will attract outside research, and that will then grow the Institute's research portfolio as we go forward. The fact that campus sustainability does not have an explicit budget attached to it doesn't really bother me, and I don't think that means that it's less important to us. I think it just means that there are other sources on campus that are already well equipped to fund such things. I don't think it would make sense, for example, to give the Institute funding to set up a biomass boiler at Abbott Power Plant or something like that, right? It just doesn't make sense because it's the folks at FNS who know what the requirements are and how to implement these things. And they have funding streams for those sorts of activities. So, I don't see that at all as a reflection on a lower importance attached to campus sustainability. Simply the fact that the nature of the flow of funding will be different in that arena than in the area of research.
Oh, thank you so much. I think, are there any more questions?